Okay, good evening, everybody. I'm going to review what we did today in class so that we're all on the same page. You didn't take any notes, but you did play with the algebra tiles, so hopefully this will go relatively quickly. Okay, first of all, I want to describe what we have here. That's actually a yellow square there. It's a yellow square, and that's to refer back to what we did in class today. And we always name all of our algebra tiles by their area. Area of an algebra tile is the name. So the area equals the name. Okay? So what I have here is I have a length of 1 and a length of 1. And so the area equals length times width, which is equal to 1 times 1, which is why we call the yellow ones a 1, because the area is 1. And typically when you draw these, you can see me draw them in the later sketches or the later notes. I'm going to just draw it like this, and I'm going to put a dot in the middle of it. All right, and that means 1. Think about a die. If you're looking at it, it's got a 1 dot in the top. That means it's a 1. So that's what I typically do. Okay, so then we look at this one, and I purposely drew this so that these lined up. So the length of this side here is the same as the length of that side there. So that's a length of 1. And if we remember in class that this side did not line up with any number of 1s. It wasn't exact. It was like 3.5 or 3.4, whatever. So we don't know exactly what that is, so we call that an x. So then the area equals length times width. So that is equal to 1 times x. So then the area is equal to x, and that's the name of this. Typically when I draw these from now on, it's going to look like this, and I just put an x inside of it like that. Okay? So this also, doesn't matter the orientation of it, this also is an x. So it could be standing up or laying down. All right, lastly, once again, we looked at this during class, and that this side and this side line up exactly correct. So that means this must be a length of x. And this side line up exactly, so that's a length of x. So then the area is equal to length times width. So the area is equal to x times x. So then this area is equal to x squared, and that's the name of it. Typically when I draw those from now on, it's going to look like this. And you see that does not look like a square, so I always put in the x squared so that you know that's an x squared, where this one is an x. So x squared is here, x is here. It doesn't have to be a perfect square. Graph paper, it is a little bit easier though. Okay, take a look at the next slide. Now I want us to draw x squared plus 2x plus 7. So we're just going to draw that real quick. So my x squared looks like this, and 2x's look like this. Now I would do this is okay. This is not okay. I would never draw it like this, because this side and this side, these two sides don't match up in length. That's a long one. If I want to put it like this, I'd draw it down here. Alright, so that's just a good habit to get into. Okay, so now I'm going to erase that. Oh no, I'm not. I'm going to go back. What am I going to do? I'm nothing. I'm going to do this. Give me 1 second here. That's this my little program. So that's better. I got it erased. So I'm going to draw it like this. And I can do it like that is fine. So I'm always lining them up. And then the last one there is going to be 7 ones, and I'll show you how. Oh, I forgot one thing. X and X. And the last one is going to be 7 ones, and here's how I do my ones typically. I just draw them in a straight line and connect them. And I go 1, 2, 3, 4, 5, 6, and put dots inside. And that should be 7 dots. 1, 2, 3, 4, 5, 6, 7. Okay, so I just represented this using x squared plus 2x's plus 7. I didn't ask you to make a rectangle out of it, I just wanted you to represent it. So what we're going to do on this one here, the next one down, is we're going to draw the equation, or write the equation for it. So for this one, what we have is we have 2x squareds right here. These are 2x squareds. I have 2x's, and I have 4 ones, like that. Okay, so 2x squared plus 2x's plus 4 ones. So notice that I don't say I have 1, 2, 3, 4, 5, 6, 7, 8 of anything. I don't add these things together because these are not like terms. We've been dealing with like terms for a while. You don't add them together. They stay x squareds, x's, and 1s, and then we can write equations. Okay, now take the next one. All right, so now in this one, I want us to draw a rectangle, right? So I want us to draw a rectangle like we were doing in class today. All right, so I'm always going to start with my big rectangle. That's my x squared. And then there's only a few places that I can put these x's. Okay, I'm never going to do this. I'm never going to put an x here and here. Okay, I never put them on opposite sides of my shape. If I want to put an x here and here on these two sides, then I'll put both of them over here. I'll put one here and one there. So I can put an x here or I can put an x there. That's it. So I'm going to go ahead and erase this one. No, I'm not, because it won't let me. Hold on. Okay, so there we go. So now I'm going to continue to draw my x's. So I put one there. I can put one here. Whoa, hello, giant. Alright, I can put one here. I cannot put one here like this. And again, the reason I can't do that is because this side here is not the same as this side here. They always have to match up. So I can't do that. I can put one down here though if I want to. I can put it like this so that the sides match up. Okay, I've got 1, 2, 3, 4, 5 to do, and I've done 1, 2, 3. My options for the last two are to put one over here, and that's an x, and that's an x, and that's an x, and put one here. Now if I do that, then when I go to place my ones, I need to have 6 ones, and I see that I have a 1 here, 2, 3, 4, 5, and 6. So it fit. Okay, so there's my rectangle. I've got my 1x squared, I got 3 x's, and I got 6 ones. Now, we're going to convert that or take a look at that as if we were talking about x squareds. Rectangles. So, if I draw my rectangle like this, in this first box here I got an x squared. In this second box here I have 1, 2, 3 x's. So that's 3x. In this box here I have 2 x's. So this is 2 x's. And in this box here I've got 6 ones. So that is plus 6. So we then can take a look at what the outside would be. So I can do this generic rectangle here. That'd be x times x. That gives me x squared. And then I go x times what gives me 3x, and that would be plus 3. And then x times what gives me 2x, that would be plus 2. And then 2 times 3 gives me 6, so it works. So that means that this quadratic is x squared plus 5x plus 6, and the factors are x plus 3 and x plus 2. If we look at our original one, this has a length of x right here. This has a length of 1, 1, and 1. 1, 1, and 1 is equal to the number 3. And then this has a length of x here. And this has a length of 1 and 1, and that is equal to 2. So this length is x plus 2, and this length is x plus 3. So it fits nicely into our generic rectangle. That's what a generic rectangle is. It's the area of a rectangle. All right, take a look at the last thing here. Okay, so here we have a quadratic, and we would like to create a rectangle with this. So I'm going to start by putting my pieces out there. So I have an x squared. And then I have 7 x's. 1, 2, 3, 4, 5, 6. They're not the most perfect x's, but they're all will do. And then I have 12 ones. So these are the pieces I have to place and make a rectangle out of it. Alright, so I'm going to start with my x squared. Now I need to split these x's up. Oops. I need to split these x's up so that I have them on 2 sides of my x squared. So I can put one here and one here. If I do that, I've got 2 done. And then 3 done, 4 done, 5 done, 6 done, and 7 done. That's what I usually start with, and I'm going to clean this up because that looks terrible. I usually just start by evenly put them on both sides and then see what happens. So I'm just going to redraw this one down here so it's a lot neater. How about that? Okay, so there we go. And now I need to see if my x's or if my ones will work. So I could go 3 rows by 4 rows, and of course 3 times 4 is equal to 12. So then that is the right generic rectangle. So then what I can do, from this rectangle, I can write the factors. So from here to here is an x plus, and this shape is a 4. And from here to here is an x plus, and then this shape is a 3. So my factors are x plus 4 times x plus 3. And if we factored this, whoops, let me clean that up. If we factored this generic rectangle right here, if we factored this by using generic rectangles, it would create x plus 4 times x plus 3. Okay, so that's what I got for you on the algebra tiles from today. Hopefully this clears it up and a little bit better. We're going to keep using them next week, and have a great weekend. I'll see you guys on Monday.